All right, welcome. Day 54, MCT4C. Lesson 6.1 is the first lesson in the new unit, and the new unit is on not polynomial functions. Finally, we've gotten rid of those stupid polynomial functions. This unit is on polynomial equations. And of course, what's one of the main ways to solve polynomial equations? It's with polynomial functions. So yeah, we thought we were done with the polynomial functions, but here we go. In the 3-minute review, we've just got some old stuff to do. The first one is just some exponent rules. We'll do all the number parts first. -6 times 3 times 2 is -36. And then the x parts, add the exponents, x to the exponent 4, add the exponents, y to the exponent 5. Lovely, that's done. Here we've got 3 brackets multiplied. I'm going to multiply the second 2 brackets first, and then end up with a trinomial inside the brackets, and then multiply through by the 4x. So multiplying everything times everything. And some people probably have done this enough that they could probably do this in one step, but I'm going to show all my work here. It would be okay to go straight from there to there. And notice -8 and -1 is -9, so that's where you could skip that step. And then I'm going to multiply through by the 4x, everything in front times everything in the brackets, 8x cubed minus 36x squared plus 16x. Lovely. The third one is really a lot like this one, and you might be tempted just to have the exponent apply on everything inside the brackets, but because of that minus sign, we can't do that. We have to think of it as a bracket times itself 3 times, like this. Okay? And I'm going to do the 2 brackets first. Everything times everything. Collect like terms inside that the second bracket. I'm going to end up with a trinomial inside the bracket. And then everything times everything again. Notice I got a 2-termer, binomial times a trinomial. I'm going to end up with 6 terms. I'm going to do something somewhat clever here just to help me figure out where the like terms are. So watch this. I'm going to go 2w times each of these things and write that out just like normal. All right, so 2w times, that's 8w cubed minus 8w squared plus 2w, right? That's 2w times each of those things. And then I'm going to multiply that times each of these things. And what I'm going to do is sort of write them underneath. Instead, I could write them out in a big line like this. I'm going to write them underneath. Watch this. -1 times 4w is -4w squared. -1 times that is plus 4w. And then -1 times +1 is -1. And then instead of having to figure out where my like terms are, all I have to do is add down then, right? And I see I got 8w cubed minus 12w squared. And I can't remember whether we did this last chapter, but there's another look at a way to expand a binomial times a trinomial. Lovely. Let's get on with the lesson. The lesson actually is pretty much this, is just practice expanding. Expectations, simplify polynomial expression, including those used to model real-world situation. We won't see too much real-world situations in the first bit, but we'll see what's up here soon. We have an expression for the area of each. Well, we know the area is just length times width. In this case, the length is 2x plus 1, and the width is a half x plus 3. And then we've got a bracket times a bracket. This is exactly what we were just doing. We're multiplying everything times everything else. That's all good, right? Some people call this FOIL, first, outside, inside, last, but I'm just multiplying everything by everything. That's going to be x squared plus 6x plus a half x. If you want to write it as a decimal, decimal 5 is okay as well. And then I'm going to collect like terms there, and I see x squared plus 6.5 x plus 3, and I'm okay leaving that 6.5 like that. That's just fine. For the next one, area of a circle, area equals pi r squared, where the radius, we got to be careful here, because this is the diameter, right? So we've got x plus 4 all divided by 2, right? That's the radius, is x plus 4 divided. This is the diameter, right? All right, so what do we got? We got the radius is x plus 4 all squared. So I got to watch when I do this. On the top, I'm going to have x plus 4 times x plus 4. And on the bottom, I'm going to have 2 squared, which is 4. I'm going to write the 4 out front with the pi, right? Basically, I could think of this as a fraction, right? And then the 1 times 4 goes on the bottom. And then on the top, I'm going to write down whatever this is, x plus 4 business is, all multiplied. And again, some people can do this step in their head and skip right to the next step where we collect like terms. And I'm going to actually multiply through by that pi over 4. Why not? Multiply that by those things. Pi x squared over 4 plus 8 pi x over 4. The pi gets multiplied in there. It's a number part, so this is the best way to write it. And then 16 pi over 4. Now notice that this first term can't be simplified, but these other two can. I can go 8 divided by 4 and get 2, so I would be, it would be a communication error not to simplify that. Same as 16 divided by 4 is 4 pi. And there's that one. There's an expression for the area of that bad boy, no matter what x is. Polynomial expression. What do we got? Example 2, consider the diagram of the box shown. Give an expression for the volume and the surface area. Well, it's been a little while, I realize, but volume is just length times width times height, right? Here, the length is x plus 4, the width is x plus 2, and the height is x plus 1. And I'm just going to, I put them in here. And this is going to give me an expression for the volume that depends on x. It doesn't depend on the length, width, and height. It just depends on x. So I'm going to multiply this all out. Notice, can I skip a step? Yeah, let's try and skip a step. I see x times x is x squared. But what's that middle term going to be now? Well, there's 2x and there's another x. It's going to be 3x in the middle, skipping a step. And then finally plus 2. Multiply everything by everything. That's x times the bracket. Now 4 times the bracket. 4 times x squared is 4x squared. And notice I wrote it underneath here so I can add down again. Pull that trick again. Why not? And please don't get frustrated if you make arithmetic errors on this, because there's lots of places to make arithmetic errors, right? So there's an expression for the volume of this shape in terms of x. Notice it's a polynomial function, isn't it? It's a polynomial function, so we didn't get to stay away from polynomial functions for too long. The surface area, well, you could remember the surface area as a big long formula. It's like 2 of those and 2 of length times height plus 2 length times, and, or not length times width because I already used that one. Height times width. I don't remember that formula. You're welcome to. What I think of is I think of just adding up all the faces. So for the surface area, I think of it more as just adding up all the faces. So for instance, the top and the bottom here is this rectangle and this rectangle, and what are the dimensions? Well, they're x plus 4 times x plus 2, but there are 2 of them. And so I could get an expression for those 2 rectangles. There's 4 and 2 are 6x. And again, where did that come from? Well, there's 4 and there's 2. That makes 6x. And then I can expand that. And that's two of the faces. That's that one and the top one. That's this one and this one. All right, that's in blue. Let's go to green. And what we'll do, let's do the front. This is going to get messy, and back. Okay, front and back is just 2 of x plus 4 times x plus 1. There's 4. 4 and 1 is 5x. Plus 4 times 1 is 4. Expand that. And then finally, last color here. What two sides haven't we done yet? We haven't done the left side here and the right side. What I'll do over here, left and right side. Well, there's two rectangles. X plus 2 times x plus 1. Multiply everything by everything. And then what do I do at the end to get the formula for the surface area is I've got to add all of these things up. I'm going to add up that and that and that all together. Well, there's 2, 4, 6x squareds. 6 and 5 and 6 is, what's that, 17x. 8 and 4 and 4 is 16. And there's a formula for the surface area of the shape. I made an error. Did you see it? Probably you saw it. Did you see that error? Right here. Let me correct it in a different color. I didn't multiply through by the 2. That should be 10 there. I didn't multiply through by the 2. That should be 12. That should be 16. Did I do it here? Yes, I did do it here. So that wasn't correct. Let's fix that up. Holy moly, what an error. What an awful start to the unit. Let's fix this up. 12 and 10 is 22, and 6 is 28x. 16 and 8, 24, 28. Okay, and there's the surface area. Dandy. Then it says, calculate the surface area of x is 3 inches. Now notice, we could go back and find, this is 7, and this is 5, and this is 4, and then, use the surface area formula like we were in grade 9 again, but we've got a formula right there, right? Well, let's just find the surface area when x is 3. Then that goes into your calculator in one step, and it looks like it's about 166 square inches. I think that's it. Is that it? That's it for the first lesson. Jammed her all into one video. Good luck on the homework, and thanks for stopping by.